Okay, today we're talking about the quadratic formula. So basically, quadratic formula is used to solve quadratics, x squared plus 3x minus 5, that kind of thing, when they won't factor. Because if you can factor them, way faster to solve them that way. We've done tons that factor. And every now and then we'd hit one that wouldn't factor. Well, this quadratic formula is what you use for that. Okay, pause for a second. All right, so mosquito repellents, that is kind of interesting. They don't actually like make the mosquitoes like sick, so they fly in and go, ooh, that smells bad, I'm going to go away. They just can't find you. That is kind of interesting thing about mosquito repellent. All right, first, what can you cancel? I like to call this can or can't you cancel. Got a catchy title. Can or can't you cancel? So I'd like you to figure out, on some of these you can cancel, on some of these you can't. I would like you to reduce the ones that you can cancel. All right, so on this one it's called can or can't you cancel, and here everybody thinks you can cancel those. Let me prove to you that you can't. It's not just like math teachers are mean and they say you can't. It just won't work. Watch, let's say I had 5 plus 1 over 5. Would you agree that that's really 6 over 5? Okay? What happens if I cancel these? Is it the same as 6 over 5? No. See what I mean? Doesn't work. Okay, so you can't cancel them when they're like that. Why? Because the difference between this and this one you can cancel those x's. Why can you cancel them in that case and you can't in this case? Yes. Yes. If you are multiplying here and you're multiplying down here, think of this as a 1 times x, then you can cancel things when you're multiplying on the top and the bottom. When you're adding, then you can't cancel across addition, is the way I've heard it before. That's the simplest way I can say it. And you can't cancel across subtraction either. But this one you can cancel. We practiced this. If you know that you have to have a 3 in all of them. Now really, just so you know what's really happening, the 3 is factoring out on the top. And it's becoming 3x plus 1. Do you remember me saying that if you can factor things, you should? If you factor this part and make it 3 on the outside and x plus 1 on the inside, then really what's happening is this is turned into a multiply problem on the top. And that means that you can cancel. Okay? 3 goes in here once, 3 goes in here 4 times. And the final answer would be x plus 1 over 4 on that one. Okay, so this one you can't cancel, so this one stays the same. Okay, let me practice that with you. So let's say you had this, 6x plus 6 all over 3. Can or can't you cancel? You can. Okay, it's not going to be as simple as just going, oh, I'm going to cancel these two. But you have 2 options. Option A, you go 6 comes out and you have x plus 1 all over 3. And then you can cancel these 2. Or, if you'd rather, you can stick to the original and go, okay, 6 goes into everything. 6 goes in here once, 6 goes in here once, 6 goes in, oh, wait a minute, it doesn't, that's 6 goes into everything. 3 goes into everything. 3 goes in here twice, 3 goes in here twice, 3 goes in here once. And so then, of course, divided by 1, I don't even need to say anymore. So it's just 2x plus 2. All right, I'd like you to try one like that. 8x plus 4 all over 12. Would you see if you can cancel that puppy for me? Option A, you factor the top and then cancel. Option B, you take something out of everything. This time, to keep me from having to be the checker of all things, I'd like you to check across these 2 rows check across with each other. These two rows, check across. These two rows, check across. And if you three could check, that would be good. See if we got the same thing as each other. All right, I'm curious. How many of you did the factor it on top way? All right. Person with the highest percentage in the room. Okay, that's interesting. But it is something you're used to by now. We've done this a lot. 4 goes in here twice, 4 goes in here once, 4 goes in here 3 times. So then 2x plus 1 all over 3. Raise your hand if you had it right. Okay, good. As long as you can get the answer right, it doesn't matter if you factored it first. But if, just so you know how that would have looked, what goes into both of these two? What goes into both of these two? 4. So 4 goes in here, and you got 2x plus 1 all over 12. And then you can go 4 goes in here once, 4 goes in here 3 times. Final answer, 2x plus 1 over 3. Okay, now I don't know if you like that better or not, but it works. Okay, how about this one? Factor this one, or sorry, cancel this one. Tell me what you get. One person gave me the right answer. You are correct. Yup, yup, yup. Yup, 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 yup. Nope. Yep. Yep, yep. Yep. You're an X on the bottom. It should be. Yep. Yep. Okay, bottom line on this one, you can't cancel it. Because nothing factors out of the top. And by the way, that's another way to tell if you can cancel stuff or not. If nothing factors out of the top, then you can't cancel. Okay? All right. How about this one? Simplify that puppy for me. Yes, sir. You can cancel further. You got a good start. You can cancel further. You can got a good start. That's right. That's right. That can cancel further. That's right. That's right. That can cancel further. That something went wrong with your X's. That's right. Yours got flipped somehow. You can cancel further. That one's right. That one's right. That one's right. That one's right. Right. Yours can cancel further, Miss A in the back. Yours is right. Yours somehow got flipped. It was on the bottom, and all of a sudden you brought it up to the top. Good. You can cancel further. Good, 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 good. I don't know what happened. No, I know. When you went your 4 and your 12, didn't reduce right. 4 goes into 12 more times than that. Yes, 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 yes. I saw a lot of people change their answer from wrong to right. I think we're starting to get it better. So a lot of people knew that you could cancel these numbers, and you said 4 goes in here once and in here 3 times. So they said 1x over 3x, and what's wrong with that? The x is cancel too. Cancel that, cancel that. Now I have 1 over 3. Now one thing that's important to note about canceling is technically, when you are canceling, what you are doing is saying that this, get how x over x is equal to 1. So when you're canceling, the thing is not disappearing, it's turning into a 1. Okay, that's important because what if everything on top cancels? Do you get how 2x, the x can cancel the x, and the 2 and the 5, you know, as people go like this, 2 times 5 is 10, and then they cancel the 2's, and they think the answer is 5. What would the answer for this one really be? 1 over 5. Okay, try that one like that. 3x over 12x Yes, 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 yes. Yes, yes. That one's a yes. Yes, yes. Can't tell. It's, oh, yes, good. It's just, can you make your brightness a little higher? Good, 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 good. All right, pretty much everybody getting this one right. Good, okay. So this one, what went into both? 3 goes in here once, 3 goes in here 4 times, x cancels, and technically they're making ones, just reminding you. Final answer, 1/4. Okay, so back to that original screen. Can or can't you cancel? I want you to look at this with new eyes again. Don't go back, on your iPad, but just look up here. Can you see that these are actually pretty easy ones? All right. So this one, what's the answer again? Can't cancel. What's this one? 3. What's this one? In your head. X plus 1/4. And if you check by seeing, will the top factor? Yeah, it will. That's a smart way to tell whether or not you can cancel. Because if the top factors, it becomes 3x plus 1/2. Now the reason, 3 goes in here 4 times. So 3x plus 1/12. And then you go 3 goes in here once and 3 goes in here 4 times. So x plus 1/4. Okay, now the reason we're doing all of this, of course, is because you end up with problems like this, and after you've stuck in all your numbers, they look like this. Would you please get to this screen? It'll be 4 or 5 slides down. And simplify this first one. We've practiced this a lot, so you're probably going to be good at it. You should be asking yourself, what goes into everything? Oh, nothing goes in. Wait a minute. Do you guys have this slide? You don't have this slide. I'm sorry. Oh, what? Somebody found it. It's way down, apparently. Handwritten in red or blue and red ink. Thank you for finding that. Yes? Oh, great. For a 75? All right. Thank you. Sorry, I guess I'm assuming there was only one set of notes for you to upload, so it's probably that my smartboard needs to be fixed. So instead of your notes need to be fixed. All right, so hopefully here you're seeing that the square root of 27 needs to get fixed first. You remember that? Square root of 27 is really root 9 and root 3, but you don't write root 9 and root 3. You write what? 3 root 3, because square root of 9 is 3. 3 root 3 is what you write. So all of that changes to 3 root 3. And now you ask yourself, either A, it says this, -6 plus or minus 3 root 3 all over 9. I'm curious, now I know that you're biased by the fact I taught you this already. And I taught you, oh, what goes into this, what goes into this, what goes into that. Okay, but do you think if I taught it to you over again, that it would have been better if I taught you to factor this top part out and then cancel stuff? Or do you like it better? I'm going to ask you to do that in just a second here. If I were to factor this out, what goes into both of them? 3 does. And I'd have 3 comes out, and I'd have -2 plus or minus root 3 all over 9. And once I do that, I can cancel the 3 and the 9. 3 goes in here once, 3 goes in here 3 times. That's option A. Option B is to go 3 goes in here twice, 3 goes in here once, 3 goes in here 3 times, and the final answer has to be rewritten anyways as that. -2 plus or minus square root of 3 all over 3. So, which way do you think is better? Do you think the blue way or the green way is better? I'd like you to slide to a spot where you have a blank area on your screen and then write blue or green for me. Which way do you think is the smarter way for me to teach this in the future? I'm fine with either one. Should I teach you the green way, which you don't have to look at any of the blue? See, the green way is just that. You factor stuff out. The blue way is where you say what goes into this, what goes into that, and what goes into that. All right. And I'm going, interesting. Okay, I've got about 4 greens. Everybody else said blue. All right, thank you. I'm just curious. I really don't have an opinion yet. I can see I could go either way on that, and thank you for your opinions. I'll stick to blue for now. All right, so here's a typical question. Examples. All right, well, let's actually do this one. A would be 1. Do you get how there's a 1 in front of this? B would be the 9, and C would be the 10. And then all you have to do is put that into the quadratic formula, which is x equals negative b. But if I were you, right away, I would write opposite of 9. Negative b is really negative 9. Negative 9 plus or minus the square root of b squared. I'd probably make a parentheses squared and drop in the b minus 4ac. I always make 2 sets of parentheses right there. All over 2a, and 2 times 1 is just 2. This part right here, everybody knows how to square a number, so the 9 squared is never a problem. But that part I just circled right there is where almost all the mistakes are going to be made on the test. People screw up that part, so be really careful on the minus 4ac part. Okay, so minus 4 times a is 1 times c is 10. Because, see, sometimes there's an extra negative in there that people don't catch. There's only one negative this time, so it is negative 40. So it's 81 minus 40, so that's going to be 41. So you would have negative 9 plus or minus square root of 41, which I don't think has, has anybody found anything that root 41 breaks into? I don't think so. I think, isn't 41 prime? Okay, so I think that one can't be simplified. All over 2a, which is 2. Cool. Now, if you had to use a calculator, the only part you would do differently is you would know what the square root of 41 is. So I asked you to grab your calculator, and I see you have it out on your desk, and that's awesome. So would you please find what the square root of 41 is? And we're going to agree that we're going to go 2 decimal places is good enough. So the square root of 41 is what point, what? 6.40. And since it's 40, I can just say 6.4. All right. Now, you can't just say it's negative 9 plus or minus 6.4 all over 2. You have to actually get both answers. You do this once with plus 6.4. And then you do it once with minus 6.4. Now remember, this part here has to be in parentheses or your calculator will get confused. And it will, if you don't have parentheses there, it'll think you just want the 6.4 to be divided by 2. Where you really want to have this and this together and then divide it by 2. So don't forget the parentheses. Obviously there is no plus minus key. So type it in once with a plus. Remember the parentheses, and once with a minus. And then would you please compare with the kid sitting next to you? Give them a second if they're not done. All right, so we have negative 9 plus 6.4, which would be negative 2.6 divided by 2, which comes out to negative 1.3. Did you guys agree? Okay, good. And then the other one is negative 6 minus, or negative 9 minus 6.4, and that makes negative 15.4 divided by 2. And that is half of 15.4, which would be half of 15, which is 7.5, and then half of the 0.4 is 0.2, so it'd be 7.7. Negative 7.7. Did I get that one right? Yay. Okay. There's your 2 answers. Notice you have 2 answers instead of a big giant expression. So the calculator is kind of handy because it gives you two answers. Now, think about that. That's where it would touch the x-axis. That's the point of these. These are the roots, the zeros, the x-intercepts. Okay? And they touch at decimals. Note all the other ones we ever did touched at whole numbers because we were able to factor it. All right. So your homework. Let's get to your homework right now so I can tell you which ones you can skip because we are going to cut this down a bit. I am not giving you much time to work, so I'm a reasonable person. On this assignment 7.4b, I'll assign you less than normal, but that's all I have for the video for today.